Next up, we're going to talk about method 3 in general. So if I open method 3, you can see that the inputs are really done here in this table with up to 10 different components. In general, we have air on one side of our above grade assembly and air on the other side. Air inside ceilings, for example, is 0.60. Outside air is 0.70. We're going to show you how to get those. But the way this table is organized is you just type in all the components here. You type in their information. Maybe I've got drywall, maybe I've got framing and insulation, and then I've got sheathing and cladding, for example. Imagine all these had an R value of 1. As I type these in, you're going to see this number here going up. This is the sum of all of these numbers. So this is how you build your assembly, component by component by component by component, and then all of those add together to give your R value. You decide what type of assembly you want to save it to, either a wall, ceiling, foundation wall, floor, or header. By interior foundation wall, we mean the framing and insulation and drywall and any part of the assembly that's built on the inside of the drywall. The thing that's unique about this is that there's not an exterior air film, but everything else there will be. So firstly, you might be wondering, how do you know all of the components of your assembly? Well, for those of you that are new to this or unfamiliar or just want to be very thorough, we've made a table over on the very far right that shows typical components of assemblies. So for each type of assembly, we list the common components. This is not going to be every wall, but this will be the majority of them right here. So interior air film, interior finish, framing and insulation, sheathing, exterior insulation, if there is any, that's like rigid foam on the outside of your sheathing, cladding, your hardy board or your wood or your stucco, and exterior air film. And the same thing with floors, ceilings, etc. So let's say I wanted to define a wall. If I were to copy all of these components in the wall, we would have interior air, interior finish, framing and insulation, sheathing, exterior insulation, cladding, and outside air. Now it's just a matter of finding the R value for each of these components. You do that by using these two search tools down here. One is for anything continuous. That means it spans the entire wall. Sheathing, for example, drywall, for example. These things are on the entire wall. There's no thermal bridging occurring there. The common thing where we see thermal bridging is framing and insulation, because in some of the wall you have stud and in another part of the wall you have insulation. Stud, insulation, stud, insulation. For that, when we have framing and insulation, anything with thermal bridging, we're going to use search tool number 2. And we're going to show you how to search for these in future videos. The other option is that you can use these tables over here for quick R values of common components. For example, all of your common air films are here. All of your common sheathings and interior finish like drywall is here. We've even got framing and insulation combinations, the most common ones anyway, listed here. And then cladding over here, stucco, vinyl, softwood, etc. For example, if I choose interior air, I can actually see that air inside of a wall has an R value of 0.68. I could also do my outside air, which is 0.17. So now I've defined those two components. What about half-inch drywall as my interior finish? I can find that over here, half-inch gypsum, and I can type in 0.45. Once I've typed in all of my components and their R value, the net R value down here is going to be the R value of that whole assembly, which I will save as my ID. Let's say I wanted to save this as an exposed wall. I could name this maybe W1 and save it to wall ID 1. Let's say I had a 2x6 wall with R22 bats, 16 on center spacing, 15.54, half-inch plywood sheathing, 0.63, exterior insulation, let's pretend I have none, and cladding, let's say it's stucco, 0.1. So this would be my wall. And if I want to save that as wall 1, I can click save. You're going to see now that you get a pop-out box. This gives you the option to define the header at the same time as the wall. If you only want to define the wall, you just have to click this button here and it'll save. If I were to click this button right now, it's going to save it automatically right to the wall. So let's do that. So you can see all that information and the R value has been saved to wall ID 1. If I come back over here and let's just save this again. But now let's imagine I want to define the header with it and I click save. If I want to define the header with the wall, I just need to enter in these 3 fields. So these are just bullet points. Which component is the wall framing and cavity insulation? That is component number 3. So I'm going to type 3 or choose it from the dropdown. Input insulation value in the header or rim joist space. I'm going to assume it's the same as in the walls. And is there interior finish? If so, which component? Ours is component 2. That's our drywall here. And then I click save. So now the wall description in R value has been saved just like before. And also we've saved a header with this wall as well. So that's how you save assemblies using method 3.